Imagine if you could be in two places at once. Sounds impossible, right? Well, not in the quantum world. Here, particles lead a dual life, sometimes behaving as particles, sometimes as waves. It's a realm where the conventional rules of physics are turned on their heads, where the impossible becomes possible. Welcome to the quantum realm, a world of wave-particle duality, a fundamental concept that will make you rethink everything you thought you knew about reality. So strap in and prepare for an exciting journey into the microscopic world of quantum physics. Ever heard of Schrödinger's cat? It's a thought experiment that perfectly illustrates the concept of quantum superposition. This mind-bending concept suggests that a particle can exist in multiple states at once, until observed. Imagine a cat in a box with a deadly poison that might be released. Until we open the box, the cat is both alive and dead. Yes, you heard it right. Both states exist simultaneously. Only when we peek inside does the cat choose a state, alive or dead. This is quantum superposition. It's as if the universe is saying, why choose one state when you can have them all? Now let's take a leap from superposition to another quantum wonder, entanglement. Picture a pair of gloves. If I told you that I have a left glove in my hand, you would immediately know that the other glove is a right one, without seeing it. Simple, right? But here's where quantum physics throws a curveball. In the quantum world, two particles can become entangled. This means that the state of one particle is intrinsically linked to the state of the other, no matter how far apart they are. If we change the state of one particle, the other changes instantaneously. This happens faster than the speed of light, defying Einstein's theory that nothing can travel faster than light. This isn't just theoretical mumbo-jumbo. Quantum entanglement has been experimentally verified and forms the basis of technologies like quantum computing and quantum cryptography. It's as if these particles are playing a cosmic game of Simon Says across the vast expanse of the universe. So we've got particles that can be in multiple states at once until observed, and particles that affect each other's states instantly, despite being galaxies apart. This is the strange and fascinating world of quantum physics, where the rules of the game are nothing like what we're used to. Mind-boggling, isn't it? But that's just the tip of the quantum iceberg. Now, what if I told you that just by observing something, you can change its state? Welcome to Heisenberg's uncertainty principle. In the quantum realm, the mere act of observation plays a peculiar role. This is known as the observer effect. Let's say we have a quantum particle. The moment we try to observe it, to pin down its exact position or speed, it changes. It's as if the particle knows it's being watched and decides to behave differently. It's a bit like trying to take a photo of a mischievous child who never stays still. But why does this happen? Well, it's because to observe a quantum particle, we need to interact with it in some way, maybe shoot a photon at it. This interaction disturbs the particle, changing its state. It's a bit like trying to measure the speed of a car by throwing a ball at it. The car's speed will change as a result of the impact. Now let's move on to the uncertainty principle, another brain-twisting concept from Heisenberg. This principle tells us that we can never simultaneously know both the exact position and exact velocity of a particle. It's not because our instruments aren't precise enough or because we're not clever enough. It's a fundamental feature of the quantum world. Imagine you're trying to take a photo of a fast-moving hummingbird to determine its speed and location. If you use a fast shutter speed, you'll get a sharp photo showing its position, but the wings will be a blur, so you can't determine the speed. Conversely, if you use a slow shutter speed, you can see the wings flapping and estimate the speed, but the bird's position becomes a blur. This is the essence of the uncertainty principle. The more precisely we try to measure the particle's position, the less precisely we can know its speed, and vice versa. So, the more precisely we try to measure one quantity, the less precisely we can know the other. It's a universe of probabilities. You might be asking, why should I care about quantum mechanics? Well, did you know your computer wouldn't work without it? Quantum mechanics has been a game changer, giving us transistors, lasers, and even paving the way for quantum computing and encryption. And it's not just about tech. Quantum theory has reshaped our understanding of reality itself, stirring up philosophical debates. So the next time you use your smartphone or computer, remember, you have the strange and wonderful world of quantum mechanics to thank.